A prime number is one that's divisible only by 1 in itself. A composite number is a number that's a multiple of at least 2 numbers other than itself in 1. The Wonder Number Board is the best way for kids to grasp this concept because it provides visual evidence that reinforces these definitions.
On the Wonder Number Board, we have prime numbers and composite numbers. All the prime numbers have circles written around the number. Examples of prime numbers: 11, 13, and 19. And when you have a prime number, it's impossible to put a rectangular array on the board to match that prime number, and it proves whether a number is prime or not. For example, if we put 11 chips on the board, when we have 11 chips, there's no way that we can rearrange this array to show that it's a composite number. So there's always one missing. That means there's a prime. If we move these chips over here, we still have one missing. If we move these chips over here, we cannot make a rectangular array with 11 chips. So if you can't make an array on the board, then it's definitely a prime number. The next number that we're going to prove that it's prime is 13. We're going to take 13 chips and try to make a rectangular array on the board. And there's 13 chips. 13 chips, there's always one extra. The other problem was there was a problem with the array. There's one extra again. No matter which way we face the array, turn it, we always have one chip left over. So it doesn't make a perfect rectangular array. So if it doesn't make an array, it's a prime number. So this is 13, and it's a prime number. It's circle. The next number that we're going to make an array of is 19. 19 is a prime number, so we're going to fill that in. Now, we have 19 chips on the board. We can't make a rectangular array, so we have 19 this way. If we move the chips over here, we still can't make an array. There's always a chip missing with 19. If there's a chip missing in the array, then it's a prime number. Now, the other kind of numbers on the board are called composite numbers. If we use 6 as a composite number, 6 does not have a prime circle, so it must be a composite number. All composite numbers must be able to make a rectangular array. If I take 6 chips, I can do 2, 4, 6, I make a rectangle. No matter which way you face it, you always get a rectangle with a rectangular array for a composite number. 6 is a composite number because I can make a rectangular array. Now if I want to change that to 14, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we can make a rectangular array out of this. It's a composite number. What we'll do is we'll just move these chips over, and now we have a rectangular array of 2 sets of 7, so 14 is a composite number. The third example we're going to show of a composite number would be 8. We have 2, 4, 6, 8, and we have a composite number here because we've shown a rectangular array in this fashion. We move the chips around, we still can see a rectangular array. If you can make a rectangular array of a number, it's a composite number. So this is 8 is a composite number. It also does not have a circle, so it's not a prime.